So in this tutorial, we're going to go over three different statistical plots using Seaborn. So we're going to start off by importing Seaborn as SNS, and let's import matplotlib.pyplot as PLT. Now you might see Seaborn as SNS or as SB. People use different notations, so I personally like SNS. Now, first we're going to load our dataset using sns.load underscore dataset. And in this case, let's use the penguins dataset. Now to view this, we could do something like df.head. And now we can see we have our data set here. So the next thing we're going to want to do is we're going to define our scatterplot. So we're going to do plt.figure. We're going to define the size of it. So fig size is going to be 10 by 8 or 12 by 8 should be good. Perfect. So next we're going to do sns.scatterplot. And if you're familiar with R, I use that as my reference whenever I decide to use Seaborn. And that's because it's very similar in the sense of you define an X and a Y variable. And you can see here that we set a hue, and this is just defining what we want to be color coded. In this case, we use species, and you ended off with data equals df as you would in R. And now in the next line, we're going to go down one more time, and let's just title this plot, and we'll name it bill length versus bill depth. Oh, that's his bell. Bill. And we'll do plt.show to show our graph. We can now see we have a nice scatter plot of all the different species. So this would be the Adelie, I believe that is, chinstrap, and Gentoo. Now our next plot's going to be a box plot. So we can come down here and we can come up and we can copy this code and just repaste it down here. Now here we're going to do snx.boxplot this time. And we're going to do the same thing with X, but we're going to define it as species this time. And our Y is going to be flipper length. You can see here we're doing the same thing we did in the last plot. We're defining an X and a Y, a hue, and then data equals df. Also, we're going to title this. We can come down and see it ran, but we can do some customization. So we're going to title it flipper length by species. And we'll do plt.show again. And that just gets rid of this. Zoom out, and now we could see here how it plotted. So we now have our title. We can see our Y, our X, and our box plots. Now for the final plot, we're going to plot a histogram. So same as we did before, we can copy this. And we can come down to the next line. And as you could guess, it's sns.hist, but we can just add plot to the end of it. And what's really helpful too is you could use this as a guide as well. You could put data in the front. Personally, I'm used to R where you put data at the end. So that's just how I personally do it. Now, same here, we can do X equals body underscore mass underscore G. And we don't need a Y here as Y is just going to be the count. Now the customizations here are going to be slightly different. We're going to start off by defining our hue. We're then going to follow that off with KDE equals true, which is just a kernel density estimation. And then we'll also have bins equals 20, which sets how granular we want our histogram. And we can end that off with data equals df. Now, once again, we can title it. And this is going to be body mass by species. And lastly, plt.show. And I personally find this to be one of the more useful histograms. In Matplotlib, this takes a lot longer to plot, and it's a little bit more complicated. Here, we can plot all three of them at the same time, and we can get the kernel density estimation